Okay, so we learned yesterday how to add and subtract polynomials. Okay, today we're going to learn how to multiply them. I multiply using the area model. You need to get out your notes. Okay, so let's just review. Area equals length times the width. Okay, so in order to do that, we're going to draw a box here. And I'm going to divide it into little pieces. So my length, or my width here is the negative 2x squared. The length is the x squared plus 3x plus 4. Okay. So we want to find the area of all the little pieces. Okay. We're going to find the area of all the little pieces and then add them all together to find the total area of the whole rectangle. In order to do that, we find the length, which is x squared here, times the width, which is negative 2x squared. We multiply them, length times width, and get 2x to the fourth. Remember, when you're multiplying things with exponents, you add the exponents. The next one, the length now here is 3x. The width still is negative 2x squared. So 3 times negative 2 is negative 6. And this is to the first power, so x to the third. The next one is the length of 4 times negative 2x squared, which gives me negative 8x squared. Then we just add them all together to get the area of the whole rectangle. So there are no like terms, so we just get negative 2x to the fourth minus 6x cubed minus 8x squared. Okay, and that's what I get when I multiply those two together. Okay, you guys do the next one. X cubed plus 12x squared minus 20x. A lot of us had the wrong sign here. So check your signs. A negative times a negative is a positive. Okay, now we're going to multiply two binomials together. Okay, using the area model. It says find the area of the green rectangle. I don't know why it's called green, because on your page it's blue, and on my page it's gray. But maybe in the book it's green, I don't know. So the same idea. We're going to multiply the length, or the length times this width of 5x here. So 2x times 5x is 10x squared. They're going to multiply this length of 4 times this width of 5x. And 4 times 5x is 20x's. They're going to multiply this length of 2x times this width of 2. 2x times 2 is 4x. And then we're going to multiply this length of 4 times this width of 2 and get 8. Very good. Then we're going to add it all up. The 10x squared goes here. You can notice we do have like terms. 20x and 4x have the same variable and the same exponent, so they're alike. So I add 24x. And then I get plus 8. So that is my polynomial. Any questions over that? Okay, once you guys do the next one. Okay, so our answer on this should have been 14x squared plus 11x plus 2. Okay. And most of us got that. Let's review. So 7x times 2x gave me 14x squared. Then the 2 times the 2x gave me 4x. Then the 7x times the 1 gave me 7x. And then the 2 times the 1 gives me 2. We have the 4x and the 7x become 11x. Okay, so that's how we get the middle term of 11. The 2 and the 14 are already there. Any questions over that? Okay, let's move on. Now we're just going to multiply two binomials. The only difference now is going to have some negative numbers. So you have to keep track of your negative numbers. So we still draw a box. Okay, the length and width, it doesn't matter which one you write where. I could put the 2x plus 1 over here, and I could put the 5x minus 4 here. Doesn't matter. You'll get the same answer in the end. But it's the same idea. I'm going to multiply. 5x times 2x is 10x squared. Negative 4 times 2x is negative 8x. 5x times 1, length times width, is 5x. And then negative 4 times 1 is negative 4. Then we add up all the little pieces to find the area of the big thing. So I get 10x squared. Negative 8 and 5 are like terms. So that gives me negative 3x. And then minus 4. And then that's my area of the big rectangle or big square. Any questions? Okay, you guys do the next one. Okay, we should have gotten 18x minus 30. Any questions over that? Okay. Can you use an area model? Oh, we don't need to use that one right now. Okay. Now we're going to multiply a binomial times a trinomial. A binomial times a trinomial. Same idea. I'm going to draw a rectangle. This time I need to divide it into 3 pieces. So we have the binomial on the side. And then we're going to multiply the length and width and find all the area of these little pieces. So we have negative 3x squared times 2x is negative 6x cubed. Then 4x times 2x is 8x squared. Then negative 7 times 2x is negative 14x. Then negative 3x squared times negative 5 is a positive 15x squared. Then 4x times negative 5 is negative 20x. And negative 7 times negative 5 is a positive 35. Then we just write it all out. Negative 6x cubed doesn't have any like terms, so we just leave it. My next biggest degree is the 8x squared and the 15x squared. Okay, they're the same sign, so I'm going to add and get plus 23x squared. Then the next one is negative 14x and negative 20. There are two x's, so I combine those. Good, they're the same sign, so I'm going to add and get negative 34x. And then plus the 35. Okay, so that is the area of that big rectangle. Any questions over that? Okay, you guys do the next one. Okay, so our answer should have been, let's do work this one out. So negative 3x squared plus 1, 2x squared plus 3x minus 4. We should have negative 6x to the fourth here. X squared times x squared is x to the fourth. 3x times negative 3 is negative 9x to the third. Negative times a negative makes that positive 12x squared. 2 times 1 is 2x squared. 3x, and then negative 4. So negative 6x to the fourth is my first, the largest degree. Then negative 9x cubed. Then I have 12 and 2, they're the same sign, so I'm going to add and get 14x squared. Then 3x and negative 4. Any questions over that? Okay. Okay, the next one asks us about closure and multiplication. Why is it important that the product of two polynomials have only whole number exponents? Okay. The key here is because we want it to be closed under the operation of multiplication. Polynomials are closed in the operation of multiplication. So let's review what closure property means. Yes, if I write it, you write it. Sorry, my pen is. The closure property is when you multiply sorry, my pen is not working all of a sudden. Give me a second, it's kind of being a pain. Okay, when you multiply two numbers together and you get the same type of number, so let's review with integers. We all know what integers are, right? Negative and positive whole numbers, okay? So if I add two integers together, so if I add 2 plus 5, what's 2 plus 5? 7. Is 7 an integer? Yes. Then we say that that is closed under the operation of addition. Because when I add two integers together, my answer will be an integer. Okay? So let's try with subtraction. 2 minus 5 is what? Negative 3. Is negative 3 an integer? Yes, it is. Okay? So we say that integers are closed under the operation of subtraction. Because when I subtract two integers, my answer will be an integer. Let's try multiplying. What's 2 times 5? 10. Okay, is 10 an integer? Yes. So integers are closed under the operation of multiplication because my answer will be an integer. What about division? What's 2 divided by 5? 2/5 is what kind? Like a decimal, right? 0.4. Okay, is 0.4 an integer? No, it's not. Okay, so integers are not closed under the operation of division because if I divide two integers, I will not necessarily get an integer. Does that make sense? This is the same thing with polynomials. Although polynomials are a little bit more complex than integers, okay, it is the same idea. Okay, if I add, subtract, and multiply polynomials, just what we've been doing today and yesterday, my answer always ends up being a polynomial. Okay? So that's why the closure property is important. When you multiply, add, or subtract polynomials, is a polynomial. This is going so well until right this minute. It's not wanting me to finish writing. Okay, finish writing polynomial for me. There we go. Oh. Okay, any questions over that? We should have written this down. Okay, so polynomials, we would say polynomials are closed under the operations of adding, subtracting, and multiplying. Any questions over that? Okay. Any questions? Okay, now we're going to suppose the height in example 6 were 1.9 times the width, but all the other conditions were the same. What expression would represent the area of the phone surface not occupied by the screen? Okay, so in example 6 in our book, they're referring to example 6, they have a picture of a phone. Okay, and they're asking you to find the area of the phone that isn't taken up by your screen. So we see the phone. They want the area that's not taken up by the screen. So I'm going to draw a picture of our phones. Okay? Right here. Good. Then you can use my phone as reference because you've seen a phone in your lifetime. So we're going to draw a picture. Okay, we're going to have my phone be very square. Okay, so there's my phone. Okay. Yes, it is. Okay. What they're saying is that your screen, the length is X, or the width is X, and the length is 1.9 times the size of that. So this is 1.9X. They're saying the total length of your phone is 1.9x plus 3. And this length, the width right here, is x plus 1. Okay, that's what the book shows. We want to come up with how can we find the area of the space not covered by my screen. So this little piece is right here. All these little pieces right here. Anyone have a good idea on how we can do that? That'd be having find the area of the whole phone, right? Do I want to add them together? Do I want to add the two pieces together? Or what I'd like to do here? To find just these little inch between the side. I'm going to do what? Subtract the area of the screen, right? That's exactly what we're going to do. We're going to find the area of the whole phone and take away the area of the screen. Okay, so we want to break this up. So we're going to have the area of the phone minus the area of the screen. Any questions over that? So our area of the phone is 1.9x plus 3, and then times x plus 1. We're going to multiply that together. So 1.9x times x is 1.9x squared. 3 times x is 3x. 1.9x times 1 is 1.9x. And 3 times 1 is 3. So the area of the phone is 1.9x squared plus 1.9 and 3 is just 4.9. And then plus 3. They want to find the area of the screen. The area of the screen is 1.9x times the length of x. So it's just 1.9x squared. Okay. Once we find that area, then we're just going to plug it in here. The area of the phone is 1.9x squared plus 4.9x plus 3. Oops, I forgot to put an x there. And then the area of the screen is 1.9x squared. Yes. Yeah. Okay, so when we subtract those two, I just combine like terms. 1.9x squared minus 1.9x squared is 0. You have 4.9x plus 3 is the area that does not include the screen. Any questions over that? We're good? Okay, next page. Okay, so we're on this page. Do you understand? Okay, I want you guys to answer numbers 3 and 4. Mercedes states that when multiplying that monomial times the trinomial, the product is this. What is Mercedes' error? And when multiplying polynomials, why is the degree of the product different from the degree of the factors? Okay, for number 3, Garrett, what was the answer for number 3? What did you get? What was wrong with Mercedes' error? What was her error?
Oh, I didn't do that. I just did the problem. I forgot to do what was here.
Okay, what'd she do wrong? Look at it. If you did it correctly, what is the difference between yours and hers?
He multiplied the exponents instead of adding them.
Very good. Okay, Mercedes multiplied the exponents, and we should be adding the exponents. Okay, any questions over that? Okay, number 4. Who thinks they got number 4? Yep.
Because when multiplying polynomials, you're bound to add the exponents to the factors, so by nature the degree will change by addition.
Very good. So the rule of exponents is what changes the degree. When you're multiplying things with exponents, you're going to add the exponents. And since the degree is the exponent, it's going to change. It's going to become greater than the factors. Does that make sense? So something like that you should have written down. Okay, any questions? Okay, I'm going to have you guys work on numbers 7 and 8 just to get a couple more practices in.